Hello all. Now I am going to discuss one more root locus problem by adding another rule, another rule of construction for root locus. So till now we have completed 6 rules up to breakaway point, and we have discussed how to get the breakaway point, how to get the valid breakaway point, and also we have discussed some predictions of breakaway point. Okay, now I am going to discuss about rule 7, that is intersection of root locus with imaginary axis, with imaginary axis. So the roots of the auxiliary equation at k is equal to k marginal gives the intersection of root locus with j omega axis. Okay, the roots of the roots of auxiliary equation, the roots of auxiliary equation A of s at k is equal to k marginal gives the intersection of root locus with j omega axis. Okay, so I am going to discuss two rules here. First one is, seventh one is intersection of root locus with imaginary axis, and already we have discussed this problem. G of s is equal k by s plus 2 into s plus 4. For the same problem, I am going for the seventh rule. So what is the diagram we got is, this is the diagram, root locus in the last session. Okay, so here if we observe this diagram, the root locus is touching the j omega axis at one point. This branch is touching here and this branch is touching here, and we have to find out the intersection of root locus with imaginary axis, that is the seventh. Okay, this point we have to find out. So how to get that point means, this one, the root locus, the roots of auxiliary equation. So where we heard this auxiliary equation A of s, that is while constructing the RH criteria, right? That is a difficulty we have discussed. Difficulty 2. Difficulty 1 is 0, first term 0, in a row first quotient 0. Difficulty 2 is total row is becoming zeros. Then we will consider one auxiliary equation, right? So what we have to do now? We have to construct RH criteria to go for seventh rule. Okay. So what is the seventh rule? So what is, how to construct the RH criteria? We have to take characteristic equation. So already we have derived characteristic equation in the last session. Characteristic equation is s into s plus 2 into s plus 4 plus k equal to 0. After simplification we got This is the characteristic equation. S cube 6s square plus 8s plus k equal to 0. S cube plus 6s square plus 8s plus k equal to 0. Okay. Now construct RH criteria, RH table. S cube, S square, S and S power 0. S cube 1, 8. 6k. 6 8 48 minus k by 6. It is 0. And I will have k here. Okay. So to the system to be stable, first column of the RH criteria should be positive, that is greater than 0. So 48 minus k divided by 6 greater than 0 and k greater than 0. 48 minus k greater than 0, k minus 48 less than 0, k less than 48 and k greater than 0. Okay, so here the range of k, is in between 0 less than k less than 48. And what is k marginal? It is 48. We got. Okay. So now we have to consider the auxiliary equation. So always the auxiliary equation is second order, even polynomial of the second order. 6s square plus k equal to 0. So a of s is equal to 6s square plus k and make it equal to 0. So what is k value we got? 48. So we have to consider the auxiliary equation at a k marginal. So 6s square plus 48 equal to 0. So s is equal plus or minus j root 8. So minus 48 is nothing but 48 divided by 6 is nothing but plus or minus j root 8. Root 8 value is 2.8. Okay. So at plus or minus 2.8 j, the root locus is touching the imaginary axis. This is plus 2.8 j and this is minus 2.8 j. Similarly, here along with the root locus, the asymptotes are also touching the j omega axis. This branch of asymptote is touching here and this branch is touching here. Okay, so we have to go for another rule. What is another rule? Eighth rule is about intersection of asymptotes with j omega axis. Okay, so how this will be calculated? Intersection of asymptotes with j omega axis. Okay, this will be calculated by using the formula tan theta is equals to y by x. So here y is equals to tan theta into x. Here x is nothing but centroid. Why we have to consider the centroid means, see, this is the diagram. Always the asymptotes, the intersection point of asymptotes is nothing but the centroid. And what is a centroid? Minus 2. Okay, so this is always, asymptotes are always a straight lines. You have to consider this triangle. Okay, so tan theta is nothing but y by x, or theta is always calculated as theta is equals to tan inverse b by a or y by x formula, opposite by hypotenuse. y-axis divided by x-axis. So tan theta is equal to y by x. Okay. So here y is equal to tan theta into x. X is nothing but the centroid. Always you can consider x as a centroid because from the centroid only the emerging of these asymptotes will takes place. So x is nothing but here it is centroid. Simply the distance between origin to the centroid is -2. So now substitute. Only you have to consider the distance. Okay, it is always a magnitude you have to consider. Minus values you should not consider. So y is equals to, what is angle theta? It is 60 degrees. Tan 60 degrees into, what is the distance? It is 2. So what is tan 60 root 3? 2 root 3. It is around 3.4. Okay. So y you got, y is equal to 3.4. Y is nothing but this distance, opposite distance, adjacent side, opposite side. So this is nothing but this one plus 3.4 j, and this is minus 3.4 j. Okay, so like this we can calculate the intersection of asymptotes with the j omega axis. Okay, so with this problem we have calculated, we have discussed up to rule 8. Okay, thank you.